Solve the following systems and determine if the critical point 0, 0 is stable, asymptotically stable, or unstable. So 0, 0 is a critical point. As you can see here, x equals 0, y equals 0, we have dx over dt, dy over dt are 0. So the following system, the question might just give us like vector xt, if we think xt as vectors xt is yt, they can give us xt equal to a times x. As the usual we know before, a is a matrix minus 4, 0, 0, minus 4. So we have repeated eigenvalues lambda minus 4 with multiplicity 2. So we have two linearly independent eigenvectors. Eigenvectors correspond to lambdas. The first one say v1, 1, 0. Second one v2, 0, 1. The solution, the general solution, is a linear combination of the two eigenfunctions. So say xt, the vectors c1, v1, e, lambda, t. t2, v2 is lambda 2t. In our case, lambda 1, lambda 2 is the same. So we have c1 times 0, 1, 1, 0. c2, 0, 1. E lambda t. c1, c2, e lambda equal to minus 4 t. This is the general solution. In space spanned by v1, we have the x-axis. Along the eigenspace spanned by v2, we have the y-axis. Along x-axis, we know that everything goes inward the origin because lambda is negative. Lambda equal to minus 4 in our case. E lambda t 10 to 0 when t is go to infinity. Same for the line correspond to v2, go inward the origin. And everything else will be a combination of v1 and v2. In this case, we have the same lambda. So the other vectors just look like this. For example, here's a few solutions. So in this case, everything go inward, go to the origin. We have a sink. The origin is a sink. It's a nodal sink in this case, and it is stable. And it's proper too, and it is stable. Everything going goes up, and it is even asymptotically stable because suppose we start here, eventually we'll move toward the origin. So the question only asks us whether the critical point 0, 0 is stable or not. And the answer is 0, 0 is stable. And actually asymptotically stable. And it is even a nodal sink in our case. And that node is proper. Each one of them is or not. They don't share the same tangent, for example. In this case, proposing. So asymptotically stable, and this is a node.